Okay, so last class we had finished up our talk about pressure, and then you had a quizzes that hopefully you did because it was due last night. Today what we're going to do is continue with the pressure and temperature notes. We're actually going to finish them up today, just working on the temperature portion of the notes, okay? So if you're looking at the calendar, we will complete the temperature notes, the temperature portion of the pressure and temperature notes, and then you will start your quizzes for that. Okay, so that one is actually, there are 32 questions in the quizzes, but probably about half of it is conceptual, so just asking you questions regarding pressure, asking questions regarding temperatures, just conceptual, no math, and then you have a few problems that have to do with the temperature conversions, which we're going to be going over today. Okay? All right, so let's go ahead, and as you see, the pressure and temperature notes, I've had some questions about this. The deadline for those notes, that is tomorrow, 8 a.m. So ideally, as soon as you are finished with your notes today, get them submitted. If you already submitted them, they are not complete because the only thing that we've gone over is pressure. So what you need to do is unsubmit them, get your notes completed, and resubmit them before 8 o'clock tomorrow morning. So again, they're not done. So you should actually unsubmit them now so that you can finish them up, all right? Otherwise, when I check them tomorrow, if you only have half of them done because you turned them in early, then you're only going to get half the credit, okay? So please make sure you unsubmit now if you already submitted them so that you can finish up your notes, all right? Okay, so I'm going to go ahead and go to the PowerPoint. And this is actually where we're picking up today, is talking about specifically the Kelvin scale, which is what we use in science, and then looking at conversions between Kelvin and Celsius. So if you see here that it has the Fahrenheit scale, Fahrenheit is what we use in just daily weather, all right? So when you look at the weather report, you know, what's going to be the high for today, the low for today, those temperatures are given in Fahrenheit, all right? But in science, if you were in the lab here, you would be using Celsius, okay? So we do that. And then, but science also uses the Kelvin scale, all right? All right, so before we get started on, yes, you are going to have to draw the Celsius and Kelvin scales, not the Fahrenheit, because again, we are not working on that. We don't use that here in the science classroom. We use either Celsius or we use Kelvin, so you need to make sure you know how to convert between those two, which we are going to be working on today. But before you do that, what I need you to do is, on your notes, we need a couple of definitions. So number one, what is temperature? So in this space, you're going to be writing a couple of things. You're going to write temperature, definition of temperature, and you're going to write the definition of kinetic energy. So we're going to have a little bit of room up here for your definitions. Here, you're going to draw the Kelvin and the Celsius scale, which I'll put back up in a moment. And then down here, we're going to define what absolute zero is. So some writing up here, a little bit of writing, your two drawings of scales. Please make sure that you can read them. And then definition of absolute zero. All right, so the definition of temperature is, it is a measure of average kinetic energy. Okay, and you will usually see me abbreviate it capital K, capital E for kinetic energy. Now, can anyone tell me what kinetic energy is associated with? You could go ahead and put your answer in the chat. What is kinetic energy? When you hear about kinetic energy, so you've probably heard about kinetic energy, potential energy. Kinetic energy is associated with what? In other words, what do you need to be doing in order to have kinetic energy? That is correct, movement. There has to be movement. So this is energy associated with motion. Okay, so the faster you're moving, the more kinetic energy you're going to have, since it's based on your speed, all right? The slower something is moving, the less kinetic energy it's going to have. So in parentheses, I'm just going to put faster equals increased or high KE. Slow equals a low kinetic energy, KE. So when we're talking about temperature, we're talking about the movement of particles, right? So think about all these particles that are moving around, constant random motion. Some are moving faster, some are going to be moving slower, all right? So as far as temperature, what happens is if particles are moving faster, then that means they're going to have more kinetic energy, which, since temperature is a measure of average kinetic energy, if the kinetic energy is increasing, then that means the temperature is increasing. So if you think about it, if you are boiling water, I put a pot, I just did it this morning, cold pot of water on the stove, turned on the heat, and then what happens to that water as it starts to heat up? So we're adding heat to the particles, all right? What does that water start to do? Does it continue to stay still? Or what do you see happening to it? Okay, so it bubbles. Okay, the reason that it's bubbling is because your water is moving faster, all right? The particles, the molecules of water are moving faster. So when you are adding heat to the water, all right, that heat is absorbed by the molecules. The molecules start to move faster, okay? Again, which means they have a higher kinetic energy. So as they move, they're moving faster because they're absorbing heat, okay, which means they have a greater kinetic energy. And therefore, greater kinetic energy means their temperature is going to go up, since, again, this is a measure of the average kinetic energy. So if average kinetic energy increases, then what happens is your temperature increases, okay? So on the other hand, if something starts to cool down, in the chat, put your answer. If something starts to cool down, what happens to its kinetic energy? If something begins to cool down, what happens to its kinetic energy? Okay, so your kinetic energy is going to decrease. And why is that? So my first question was, if something cools down, what happens to its kinetic energy? And the answer is the kinetic energy is going to decrease. It's going to go down. Now, why does the kinetic energy go down? So this is where you would talk about the motion. Why does the kinetic energy go down? Because the molecules are moving slower. Perfect. Okay, so molecules are moving slower. Kinetic energy goes down because the molecules are moving slower. And what does that mean as far as temperature? What's happening to temperature then? So as molecules slow down, kinetic energy decreases, and the temperature is also decreasing. Good. Temperature goes down because that is a measure of the average kinetic energy. Okay, that's good. All right, so now we're going to go back to the temperature scale. And then what I need you to do is go ahead and you're going to draw. You're drawing the Celsius scale and the Kelvin scale. And actually, you know what? I'm going to go ahead and write this out for you just on my paper, a simplified version of the those scales. All right, so let's have, and there's three temperatures you need to be familiar with. So let's say this one's the Celsius scale. So this is in Celsius. And I'm just going to draw a line to represent the thermometer. And then we also have Kelvin scale. And those are supposed to be horizontal. So Kelvin scale will be here. Okay, so the way that this is abbreviated, when you write temperature, if it's 10 degrees Celsius, then what you have on the end of it is degrees Celsius behind the temperature. If it's in Kelvin, there's no degree sign, it's just Kelvin. All right? So 3 temperatures that you need to know. All right, we're going to have boiling point of water, okay, I'm going to have this up here. I'm going to have the freezing point of water. And then we're going to have something that is called absolute zero. Okay, so remember that as far as your temperature, it is related to the kinetic energy. It is a measure of the average kinetic energy. All right, so if your temperature is dropping, then what happens is your average kinetic energy is decreasing. All right, so boiling point of water on a Celsius scale. Does anyone know what the temperature is, the boiling point of water? At what temperature will water boil on the Celsius scale? Okay, it is 100 degrees Celsius. On the Kelvin scale, it is 273 degrees. I'm sorry, it's 373. 373. 373 degrees. Okay, freezing point of water. What is the freezing point of water on Celsius? Water freezes at what temperature? Zero. Thank you. Freezes at 0 degrees Celsius. Okay, and on the Kelvin scale, it is 273 Kelvin. Okay, now, this is the Celsius scale. This is the Kelvin scale. Do you notice anything as far as what's the difference? How would I get from Celsius to Kelvin if I wanted to convert or change the temperature? So look and see if is there anything that's similar here?
You add 273.
Good, you add 273. So if you have whatever temperature you have for Celsius, if you add 273, okay, you will get your Kelvin temperature. All right, so that is your conversion. That's what you're working with. Okay, so to convert from Celsius to Kelvin, I'm going to go down here for a minute. I'll put that back up in a moment. All right, so to convert Celsius to Kelvin, your equation is your Kelvin equals whatever your temperature is in Celsius plus 273. That is the equation. So what do you think you would need to do if I wanted to do the opposite? Let's say that I had Kelvin temperature and I wanted to change it to Celsius. What would I need to do?
Subtract 273.
Good, subtract 273. So degrees Celsius equals your Kelvin temperature minus 273. Okay. All right. Now, one last thing that I want to talk about as far as the scale is what's called absolute zero. All right. So as we are dropping in temperature, again, what is happening to kinetic energy, your average kinetic energy? Just go ahead, several answers, put it in the chat. As we are dropping in temperature, so we went from boiling point of water to freezing point of water, our temperature is dropping, went from 373 Kelvin to 273. What's happening to your average kinetic energy? It is decreasing because your particles are slowing down. All right, now, absolute zero on the Kelvin scale is 0 Kelvin. Okay, this is 0 Kelvin. Okay, so let's try this. If this is 0 Kelvin, okay, on the Celsius scale, what would it be? Keep this in mind. I have your Kelvin. You have Kelvin is 0 Kelvin. Put your answer in the chat, please. What would the temperature be in Celsius? Good. It's going to be a negative 273 because it's 0 minus 273 equals a negative 273. So on the Celsius scale, again, that is negative 273. Okay, so what is happening here as we are dropping in temperature? The average kinetic energy is decreasing. So particles are getting slower and slower and slower and slower. Okay, at absolute zero, which is 0 Kelvin. Okay, at absolute zero, which is 0 Kelvin, this is the theoretical point where your particles are completely stopped. There is no motion. Now, if I have something like this, I'm looking at this, all right, this thermos. This thermos is made up of particles, all right? These are not stopped. They are not completely stopped. They may be stuck in place, okay, because this is solid, but what happens is even in something like this, those particles are vibrating in place, so they are not completely stopped. They are moving as much as they can, all right? They just can't move around like in liquids and gases, but they are moving, all right? So they're vibrating. When we get down to this, what we say is absolute zero. That means there is no vibration whatsoever. The particles are completely still. That's absolute zero, all right? So this is when absolute zero is the temperature at which all particle motion stops. So that means no vibrations either. Not just sitting there in place, okay? So not in one place and vibrating, but completely no vibrations whatsoever. All right, so that's absolute zero. So here's my question. Temperature is a measure of average kinetic energy, and as the temperature drops, your average kinetic energy is decreasing. Absolute zero, we say that this is where all motion stops. On the Kelvin scale, temperature is 0. Can we ever have a negative Kelvin as far as the temperature? Can we go further down here and have a -5, -10 Kelvin? Is that possible? Yes or no? Put it in the chat, please. Is it possible to have a Kelvin temperature that is less than 0, so in the negatives? Put your answer in the chat. No. Okay, so why not? Why is it not possible to have a negative Kelvin temperature? So again, think in terms of motion. Tell me about the motion. Why is it not possible to have a negative temperature for Kelvin?
Because when you have 0 Kelvin, all motion had already stopped. There's no way to go lower.
Great, that's perfect. And that's exactly it. So at absolute 0, we just said that your particles are completely stopped. There's no vibrations whatsoever. You can't get any slower than that, all right? So since you can't get any slower than that, that's as slow as you can get. On the Kelvin scale, you will not get any temperatures lower than this, okay? Because to go down further, that means it has to continue to slow down, but it's already completely stopped, all right? Okay, so, but we see that on the Celsius scale, you can go down to a negative 273 degrees, but even for this, you cannot go below this because this temperature is absolute 0. Okay, 0 Kelvin is absolute 0, where all motion stops. Okay, so let's go back to the PowerPoint. So you have your scale. So we were talking about standard temperature and pressure, STP, okay? So with your standard pressures, STP, standard temperature and pressure, you're looking at a combination of temperature, specific temperature, with a specific pressure. So the specific pressures that we had discussed before were 1 atm, 101.3 kPa, 760 millimeters of mercury, 760 torr. All of these are equal to each other. So you can use any one of those for your standard pressure, all right? Now, it is STP, standard temperature and pressure. So the standard temperature portion of that STP is 273 Kelvin or 0 degrees Celsius. Okay, so normally what will happen is in the future you may see a problem where it says that we measured this volume of gas at STP. All right, when they say that at STP, then you know, okay, well, that means the temperature was, and again, you can use either one of these because they are equal to each other. All right, so if you were doing a problem and it says it's done at STP, in your list, your givens, then you can write, okay, well, the temperature is 273 Kelvin. The pressure is 1 atmosphere, all right? So even though it doesn't state it in the problem, you can write it because it told you it was at STP, all right? And those temperatures and those pressures are set. So standard temperature equals 273 Kelvin or 0 degrees Celsius, okay? Again, those are equal to each other. Okay, as you can see from this, 273 degrees Celsius what am I looking at? Oh, up here. Sorry. Your 0 degrees Celsius is the same as 273 Kelvin, all right? So that's the temperature at which water freezes. Okay, so we had already looked at this. It says Kelvin equals, and I'm sorry, it looks a little, don't know why that happened. It was a PowerPoint, so guess that happened with the conversion to Google Slides. All right, so we have that. So this is how you convert Kelvins or Celsius to Kelvins. You're going to add 273 if you have Celsius degrees, and if you have Kelvin and you need to find your Celsius, it's going to be subtracting 273. Okay, so you have those down. All right, down on the bottom of your notes where it says standard temperature and pressure, STP, all right, what you need to do is you're going to write this down. So you can combine any of these together, all right? So, for example, I may give you a question. I may give you a question that asks, it may give you a combination of something like, let me go ahead and write this down. Okay, is this STP? And then you may be given something like, let's say I give you 0 degrees Celsius, 760 ATM. And the answer is yes or no. Is this STP? These two measurements together, is this a standard temperature and pressure? No, it's not. What's wrong with this? What is wrong with this? 760 ATM. So what should I see? You're correct. You're okay. So yes, it's not 760 ATM. I would have had to put 760 torr or 760 millimeters of mercury, or 1 ATM. All right. What about this? Is this STP? (273K) and 1 atmosphere. Yes. Okay, because again, remember your standard temperatures can be 273K or 0 degrees Celsius because they are equal to each other. And then 1 atmosphere, 760 torr, 760 millimeters of mercury, 101.3 kPa. All right. So any combinations of those kind. All right. So just be careful when you're reading these. Okay. So you may have questions like that where it's asking you, is this STP or not? All right. Choose which one. If you're given a list, which one of these, A, B, C, D, which one of these is a STP? Okay. Are there any questions? All right. So before we end this, what I want to do is just work on a couple of temperature conversions just to make sure you know what you're doing, since that is in your homework. So on the notes that you took, because you had started this, all right, you have a document that you're going to be turning in with your standard pressure. So on that, just at the bottom or somewhere on there, you can add some temperature conversions. I'm just going to do a couple. Okay, so what if you have 5K, 5 Kelvin, and you need to convert this to degrees Celsius? How would I go from Kelvin to Celsius? Go ahead and put your answer in the chat. How do I convert Kelvin to Celsius?
Add 273.
Add 273 to go to Celsius.
No, sorry, minus 273.
Good. Okay, so we're going to subtract. So the way you would do this is degrees Celsius equals 5 Kelvin minus 273. Okay, now, when you are doing this, sometimes I have students that get this confused as far as if this is going to be a negative or positive. The negative is on the larger number, so your answer will be negative, all right? So 5 minus 273 equals negative 268. And that is degrees Celsius. Remember, degree sign on Celsius, there's no degree sign on Kelvin. Okay, one more. What if I have 25 degrees Celsius and I need to change it to Kelvin? (25 degrees Celsius) and I need to change to Kelvin. What would I do?
Add 273.
You're going to add 273. And that is Kelvin. Okay, so one way to remember, do I subtract 273 or do I add 273? Think about Kelvin. Kelvin can never be a negative number. Kelvin can never be a negative number. So what is a sure way of never getting a negative answer for Kelvin? Should I be adding 273 or subtracting 273? Which one of those will never give me a negative number for Kelvin?
Adding.
To add. All right. So remember, Kelvin can never be negative. Never, never, never be negative. Okay? Lowest it will go is 0. All right. Are there any questions? Okay. All right. So your assignment. Sure, I'll put that up in a moment. Everyone else, your assignment is in Google Classroom, so you can go ahead and get started on that. You only have one chance. It is a quizzes, okay? So be careful with that. And there is tutoring today. It's Thursday at 1:15 if you need any help.